Okay. Then we have another estimating technique called learning curve method. This is a very interesting method because it's describing a very common phenomenon we can see like in daily lives. So here the three images show you that the more practice you do, the more efficient you can be, right? Those are the amazing workers, like the person who is making hamburgers in Burger King. If he has been doing this for many years, he can be very fast, right? And another person is like handling all these beers in just two bare hands. So he must be practicing this for a long time so that he can manage so many cups at one time. And the same thing to this servants. So he can manage to, put maybe 15 plates on his one arm and serve for the many tables at one time. So, but all of this, it looks so amazing, but behind that, you have to practice a lot. And this phenomenon can be described by this learning curve. So learning curve is a mathematical model that explains the phenomenon of increased worker efficiency and improved organizational performance with repetitive production of a good or service. So the more you produce, the more efficient you can be. And on this chart, the x-axis is the cumulative volume of production. So it means like how many products you are making. And the y-axis is the average time per unit. So that means like how much time costs for each unit you produce. It tells you that when you produce more products, right? When the line goes to the right side, the y will decrease, right? Which means you will have lower or fewer time cost for producing one more product. Okay. So this is a good phenomenon. That's something either workers or the businessman or a manager they want. That's why we want to practice a lot and being familiar with the process and making the process more efficient so that the average cost can be lower and then your profit could be higher if you sell the same number of products, right? So to describe this learning curve, here is the function or equation we can use. So this is the equation itself. It tells you the total cost for produce a product in the number of U, okay? So this is a very tricky equation. You have to pay attention to the variables. First, the ZU, what is the unknown variable you're calculating for? What is your ZU? ZU is the number of input resource units, like how much time, okay, needed to produce output unit U. Output unit U is just one unit, okay? You have to pay attention to this. It's just one unit, one actually additional unit, okay? So Z10, for example, means the 10th unit. It's not 10 units, it's the 10th units, okay? So let's put it here. It's the youth unit, okay? And the ZU is actually the time cost for producing the youth unit. So that's just the additional time cost for that one more unit. It's not the total cost for producing U units, okay? So not U units. What's the difference? You have to make it clear. All right, and then on the right side of the equation, you will see the K. K is the number of input resource, which we always say it's a time cost. So K is the time cost needed to produce the first output unit. So K is actually the time cost for the first product. We can imagine that it's gonna be very high because we know the learning curve is going down. So the cost for the very first product is gonna be very high. That's very true. That like if you are making the burger for the first time, it might cost you maybe 20 minutes. But after 100 or 1,000 times practicing, you might just need like 3 minutes to do that. Okay, depending on the learning rate. So the K is just the time cost for your ever first product. Okay, and then in the parentheses you have U. U is the output unit number. Like if you are looking at the 10th units, then the U is 10. Okay, it's just a number, like which unit you're looking at. And then N is called learning curve exponent. While N, you need some additional calculation. It's not always given directly. So to calculate N, you need to use S. S is what? S is the learning curve slope, or we can say it's learning speed or learning rate. Okay, it has different names, and usually it's given. So when S is given, you can calculate N using log S over log 2, and then you're gonna plug this N back into this equation. Okay, now let's take a look at this example. So we have a car design team, okay, and the design team is designing a formula car for national competition. So they spend some time to design to do the design, to assemble the car. Well, the time required for the team to assemble the first car is 100 hours, okay, so which means the K is 100 hours. Let's just copy this equation very quickly. So the equation says ZU, time cost for the youth unit is what? Is K, time cost for the first unit, times something, times U, which unit you're looking at, and then to the power of N. And N, you need to calculate it using log S over log 2. S is your learning rate. Okay. So based on the definition, the first car costs 100 hours, which means K is 100 hours. And their improvement rate is 0.8, okay? So the learning rate is, we said it's S, 0.8. Which means that as output is doubled, their time to assemble a car is reduced by 20%. This is just an explanation of this learning rate. Okay, so if learning rate is 0.8, which means it's 8%, it means what? It means whenever you produce, so the time cost for produce one car is 20% more the time cost for producing, average cost for producing 2 cars, because the number of cars produced is double. Okay, so that's what the learning rate tells you. But you don't have to worry about the definition of learning rate. Just need to know what is learning rate, and S is gonna be the learning rate. Okay. So use this information to calculate first the time it will take the team to assemble the 10th car. We said the ZU is the time cost for the youth car. So if you want to know the time cost for the 10th car, it's gonna be Z10. Okay, so what is Z10? Obviously, we're going to use this formula. And the second question, the total time required to assemble the first 10 cars. That's a total time cost. So from this one single equation, you're not gonna get this total time cost, but you can calculate Z1, Z2, right? Z3, until you got Z10, and you sum all of this up together. That's the total time cost for all the 10 cars. And C, the C question is to estimate cumulative average assembly cost for the first 10 cars. So which means you wanna add up all the time costs and divide it by 10. That's the average cost. Okay, so now let's see how to calculate this. So question number A, to calculate what is Z10, okay? So we know ZU is K times U to the power of N, and we know that ZU, we can use it as Z10, so U is 10, right? That's the specific unit we're looking at. And the K is 100 hours, and N is log S over log 2. Let's write it like that, okay? And S is what? S is 0.8. So it's log 0.8 over log 2. What's this? This is negative 0.322. Okay? So it's easy to calculate. Z10 is K 100 times U is 10 to the power of negative 0.322. Okay, what's this? This is 47.65 hours. So to produce the 10th car, you have already practiced 9 times. So the time cost is only maybe half of the cost for the first car, right? Compare these two numbers, which makes sense. All right, so that's for the question A. Question B is to calculate the total time cost for the 10 cars. Okay, so we said you need to calculate Z1 until Z10, right? So Z1 is given. That's the time cost for the first car, which is K, which is 100 hours. But Z2, you need to use this equation again. So Z2 means the U is 2, right? You're looking at the second unit. What's the time cost? It's 100 times 2 to the power of N will stay the same because you have the same learning rate, 0.8. So it's gonna be the same N, 0.322. And that is 80 hours. And Z3, you use the same equation, but U now the U is 3 to the power of N. The result is 70.21 hours. And Z4 is 100 times 4 to the power of N. It's 64 hours. So you can see that the more cars you produce, the more you practice, the fewer hours you use, right? And Z5 is 100 times 5 to the power of N, which is 59.56 hours. And the Z6 is 100 times 6 to the power of N. Excuse me. and the result is 56.17 hours. And Z7 is 100 times 7 to the power of n, which is 53.45 hours. And Z8 is 100 times 8 to the power of n. You see, the only thing changes in this equation is the u, right? Because you're looking at different u's of product. So this is 51.2 hours. Z9 is 100 times 9 to the power of n. It is 49.29 hours. Z10 is what we just calculated. So you just copy that number here, so 47.65 hours. Now you have all the time cost for each single unit, and then the total time cost is the sum of all of this. Is Z1 plus Z2 plus Z3 plus ... until Z10, and the total is 631.54 hours. Now, question C is asking you what is the average cost. So average cost is the total cost. This is average time cost to produce the car, okay? So it's the total time cost over number of cars, which is 10. So it's gonna be total time cost is 631.45 over 10. So on average, the time cost to produce one car is 63.154 hours. Okay, so this is how we use the learning curve method to estimate the time cost. Or time cost and the monetary cost are both the costs we're interested in. So all the techniques, some techniques will give you the estimate of the monetary cost, and some of them give you the estimate of the time cost, okay? All right, so this is all the techniques where we want to introduce in chapter 3. And in the next class, we're going to open up chapter 4, okay?